So the topic of this video is secant lines, and our objectives: I can find and identify a secant line, and I can find unknown lengths of secant lines using properties of secants. If you recall, a secant line is a line that passes through a circle at two different points. So what we have here, EB and ED are both secant lines. And if two secant segments or lines share the same endpoint outside of a circle, then the product of the length of one secant segment and the length of its external segment equals the product of the length of the other secant segment and the length of the external segment. So we have an illustration of that here. So if EB is one of our secant segments, then we have the length of the whole thing, EB, here, times the length of the external segment, EA. So we have here EA times EB, and that equals EC times ED. And if a secant segment and a tangent segment, remember a tangent comes in contact with a circle at exactly one point. If a secant segment and tangent segment share an endpoint outside of a circle, then the product of the length of the secant segment and the length of its external segment equals the square of the lengths of the tangent segment. And again, we have that illustrated down here. We have our tangent line EA, so the length of that squared, EA squared, equals EC times the whole length ED. An example of both of these, but first we're going to identify our segments from our illustration over here at the right. Tangent segment, remember a tangent comes in contact with a circle exactly one point, and that segment is AD. Now we're dealing with segments, so we have that line over the top. Secant segment is AC, and the external segment of that secant is AB. Now we'll look at an example. We want to find the value of x, and so this is using the first theorem. The length, or the product of the external segment and the whole segment equals the length of the external segment and the whole segment of the other one. So we set those equal to each other. 10 times 11. Whoops, not 11, sorry. We're going to restart this one. It's the external segment. So we'll start with 11 times the whole length, which is 21, equals 12 times the whole segment, which is 12 plus x. So we multiply this through, we get 11 times 21 equals 231. That equals 12 times 12, which is 144, plus 12x. We subtract 144 from both sides. That's a subtraction. We get 87 equals 12x. Then we divide both sides by 12 and get x to equal 7.25, 7 2500ths, or 7 1/4. Okay, next example. We want to find the value of x again, and this is the one that deals with a tangent. So here we have our tangent, which comes in contact once. Oops. So the length of our external segment times our secant segment is equal to the square of our tangent segment. So we, again, set it up. Square root of 3 squared equals our external segment x times our whole segment, which is 2 plus x. And we get 3 squared, which is just 3, equals 2x plus x squared. And so if we subtract the 3 over and rewrite this in standard form, we get x squared plus 2x minus 3 equals 0. And now we're going to factor. We get x plus 3 and x minus 1. So we have two numbers that multiply together to give us negative 3 and add together to give us 2. Now once we have this, we set both of these equal to 0. X plus 3 equals 0. X minus 1 equals 0. So this one we subtract 3 on both sides. We get x equals negative 3. Add 1 over here on both sides, and we get x equals 1. And since we can't have a negative length, we don't worry about that one, and our answer is x equals 1. And to review, if two secant segments share the same endpoint, then the product of the length of one segment and the length of its external equals the product of the length of the other times its external. And if a secant and a tangent segment share an endpoint outside of the circle, the product of the secant and the external segment equals the square of the length of the tangent. Remember to go online, do your reflection, ask any questions you might have, and we will see you in class tomorrow.